Bem-vindos ao nosso espaço, um mergulho profundo nos assuntos mais interessantes de esportes, ciências e temas gerais do momento. Aqui você vai encontrar conteúdo de qualidade, com análises empolgantes e descobertas fascinantes que vão expandir seus horizontes. Nossa missão é trazer informação relevante de forma dinâmica e descontraída. Queremos que você faça parte dessa jornada incrível de conhecimento e diversão. Se gostar do nosso conteúdo, não esqueça de deixar seu like e se inscrever no canal para não perder nenhuma novidade. Ative o sininho também. Aproveite!
If you love science, don't forget to like and subscribe. When you look at a spider web glistening in the morning dew, you probably see a masterpiece of biological engineering designed for one purpose: catching a meal. But what if I told you that this delicate structure is actually one of the most advanced mechanical sound processors on the planet? Recent breakthroughs in biophysics have revealed that spider silk behaves as a phononic crystal, a material capable of manipulating sound and mechanical vibrations in ways that human technology is only beginning to replicate. To understand the genius of the web, we first need to talk about what sound actually is. Sound is a vibration traveling through a medium. In the air, it is a pressure wave. In a solid material, like a guitar string or a spider's silk, it is a mechanical wave. For a spider, which often has poor eyesight, these vibrations are its primary way of seeing the world. The web is essentially an extension of the spider's own nervous system. However, the environment is incredibly noisy. Wind shakes the web constantly, leaves fall onto it, and rain pummels the strands. If the spider reacted to every single vibration, it would waste all its energy and potentially ignore real threats or opportunities. This is where the concept of phononic crystals comes in. In physics, a phononic crystal is a structure designed to control the flow of vibrations. Just as a prism splits light or a semiconductor controls the flow of electrons, a phononic crystal can create what scientists call band gaps. These are specific frequency ranges that simply cannot pass through the material. Researchers have discovered that the unique molecular arrangement of spider silk, specifically its combination of crystalline and amorphous regions, allows it to filter out low-frequency noise from the wind while remaining hypersensitive to the high-frequency vibrations of a struggling insect. The engineering here is truly staggering. Spider silk is composed of proteins called spidroins. These proteins organize themselves into tiny crystalline blocks held together by flexible, disordered chains. When a vibration travels down a silk thread, it does not just move through a uniform material. It encounters a series of structural gates. By adjusting the tension of the silk with its legs, the spider can actually tune its web, shifting these band gaps in real time. It is like a musician tuning a violin while they are playing it, but instead of making music, the spider is adjusting its mechanical sensors to focus on specific targets. This mechanical processing happens before the signal even reaches the spider's body. This is a concept known as mechanical computing or physical intelligence. Instead of the spider's brain doing all the heavy lifting to figure out what is happening on the web, the silk itself filters out the garbage data. When a fly hits the web, its wings beat at a specific frequency. The phononic properties of the silk allow that specific frequency to travel with minimal loss, hitting the spider's legs like a clear, ringing bell. Meanwhile, the chaotic, low-frequency rumble of a breeze is dampened and dissipated by the web's structure before it can distract the predator. But it gets even more fascinating. The phononic web isn't just about filtering noise, it is about localization. Because the web is a complex geometric lattice, the way vibrations travel through different radial and spiral threads allows the spider to triangulate the exact position of its prey within milliseconds. This is a level of signal processing that rivals modern sonar systems. The spider can distinguish between the rhythmic vibration of a potential mate and the frantic, irregular struggle of a prey item, all thanks to the mechanical logic built into the silk. Scientists are now looking at these biological marvels to revolutionize human engineering. Imagine building skyscrapers with phononic foundations that can filter out seismic waves from earthquakes, or creating ultra-quiet cabins for airplanes using materials inspired by the molecular structure of spider silk. We could develop new types of acoustic sensors that require no electricity because the material itself does the processing. The spider web reminds us that nature does not just solve problems, it optimizes them to a degree that seems like science fiction. What we once viewed as a simple sticky trap is actually a sophisticated acoustic computer, a mechanical processor that has been refined over hundreds of millions of years of evolution. The next time you see a web, remember, you are not just looking at silk, you're looking at the cutting edge of phononic physics. Nature is the ultimate engineer, and the web is its most resonant invention. For more incredible facts like this, don't forget to subscribe and turn on notifications.